Our lesson for today will be looking at Physics 1505. The topic for today is vertical projection, lesson 102. Let us start. As usual, we know that whenever we have practice question lesson videos, that is when we look at one of the past question papers or one of the questions based on a particular chapter that we have focused on. So today's question, we'll be looking at this particular question. The question says a test rocket is fired straight up from rest with a net acceleration of 20.0 meters per second squared. As usual, we are going to draw a picture form. So you can see this is some kind of a gun that fires up that particular rocket. So the rocket is fired up vertically from rest. So let's say we have point A and point B. So initial velocity, or the velocity at point A, is 0 meters per second. We're actually going to be run out of space. Let us use a blank page. So we have this, and then we have a rocket which is fired up. The initial velocity is 0 meters per second. Let's say this is point A, this is point B. And we have a net acceleration of 20.0 meters per second squared. Okay, we can continue our scenario. Continuing, we say actually the keywords from rest. This simply means that the velocity where it starts, it's 0 meters per second. Then when we continue after 4.00 seconds, the motor turns off, but the rocket continues to coast upward with no appreciable air resistance. What is the maximum elevation does the rocket reach? So let us go to our picture form and update what we have. So let us assume that from point A to point B, that is where the engine turns off. So from point A to point B, it takes 4.00 seconds, and then beyond this point, the engine turns off, but it continues going up. Meaning that from point B to C, let's say this is point C, that net acceleration is no longer there because the engine is off, meaning that we do not have any force applied, or that particular force that was moving from A to B is no longer there, because from B to C, that net acceleration, we can see it's 0. But we do know that we have that gravitational acceleration. So the question is, and by the way, we know that from point B to C, for it to reach the maximum height, that is where its velocity will be 0 meters per second. At maximum height, we know that the velocity is 0 meters per second. So what the question wants is the height, or the maximum height, from A to C. But in order for us to do that, we have to break it down. We have to start by calculating the height from A to B. Once we are done, we have to calculate the height from B to C. And then we add them, we'll get the maximum height. or the total height from A to C. There are a number of ways to calculate this, but let us start with the easiest method. Now this is A to B, but let us actually use another page. To make things easier, let us try to calculate all the unknown variables or unknown physical quantities from A to B. The first thing, we do have time. We know that the net acceleration is 20.0 meters per second squared. And you should also bear in mind, in this case, it doesn't mean our G is not there. It simply means that the net is the sum of all the accelerations experienced by this rocket. It's equals to 20 meters per second squared. And since it is positive, we are going to take up as positive, down as negative. Since it is positive, it means the net acceleration is upward. So in this case, we do have the velocity at this point, but we don't have the velocity at this point. We don't have our displacement. So I'm saying, let us not only calculate the displacement, but let us calculate all the unknowns we have in this situation or in this region. So let us start with the displacement. We can simply use this equation. S is equals to V initial time plus half A time squared. So S is equals to initial velocity of 0, time we have 4.00 seconds plus half. Remember that whether the object is going up or down, our 9.8 will always face down, 9.8 meters per second squared. So we have negative 9.8, and then our time is 4.00 squared. Oh wait, there's a problem. We have to be very careful whenever we are dealing with this, and you should be able to detect or identify if you're making mistakes. Our acceleration is going up in this case, and it's not negative 9.8, so we have 20.0 and then we have 4.00 squared. Then the displacement or the height it takes from A to B, from A to reach B, or the height at B from the ground, it's 160 meters. And then from here, let us calculate the velocity at B. We can use many equations, meaning that we have many ways to calculate this. We can use V is equals to VI plus A change in time. It's actually time. V is the final velocity at B, VI is the initial velocity. So we have V is equals to 0 plus the acceleration, we have 20.0, and then our time we have 4. So our V is equals to 80 meters per second. Since it's positive, it's upward. This is the velocity at B. Another option we can use VF, it's actually V, it's equals to V squared, VI squared plus 2A displacement, just to verify this. So V squared is equals to initial we have 0 squared plus 2, we have 20.0. Our displacement is 160, the calculated one. And then we are going to take the square of this, which is 2, 20.0, 160. Indeed, we get 80 meters per second. So here we have our velocity as 80 meters per second. So we can go to this information to say our displacement here, it's 160 meters, and then the velocity at this point, it's 80 meters per second. But remember, we are looking for the distance from A to C, or the maximum height. So we are covered with this one. We have 180. Let me actually use this color. We have 180 here, meters. And then from B to C, we no longer have this net acceleration, meaning that the only acceleration experienced by this is the 9.8 meters per second squared, and it is facing downwards. So if you can check, we have the acceleration, we have the initial velocity, this will serve as our initial velocity, we have the final velocity, and then we are looking for the displacement. So what we can do, we can use this equation. V squared is equals to Vi squared plus 2a displacement. The reason why we cannot use this, it does not have the physical quantity we are looking for. But we can use this equation to start by finding time. After finding time, we can use this equation. Let's put a t squared, because in this case we do want this. We have this, we have this, this, and this. The time will be from this equation. We can verify this, but let us quickly calculate using this equation. So the final velocity is 0 squared. Initial velocity is 80 meters per second upward. So we have a positive 80 squared plus 2. The 9.8 is downward, so it will be negative. Then we have displacement. And then from here, 80 squared, it's 6,400. We transpose this, we're going to have negative 6,400 equals to 2 multiplied by negative 9.8, we have negative 19.6. Then we have this s. Then we divide by negative 19.6 both sides. Then this divided by this will be 1 multiplied by displacement, it's the displacement, and then equals to 326,531 meters. So this is the displacement from B to C. So here we have let me use this color. We have 326.531 meters. Then it means to get the total, we are just going to add the 2. So the total will be 160, I mean. I've written 180 here. It's actually 160. It's a mistake. Plus the one we've just calculated, 531. We get our answer as 486,531. When we round off to the nearest decimal place, we have 487 meters. So looking at this question, the rocket will reach a maximum elevation of 487 meters above the ground. That's it for this lesson video. This is Wahula SJ. Thank you very much.